Welcome everybody to another video. In this video, we're going to be looking at histograms and frequency tables. Both of them come at the same time when you build a histogram using my steps. So let's get right to it. I always grab a table, a set of data, like housing. I bring it to a new sheet, like this. There's my raw set, my data. I like to bring it to a copy because if I destroy the data over here, I can always go back to the original and re-download. I always work with a copy in case I make a mistake, I can start again. I would state you should do this. Now, I only want to look at the age of the house. So I'm going to copy the age of the dwelling, the age of the house column to the tab called age of the house. I'm going to eliminate this histogram so I can show you. If you wanted to break the age of the house based on the type of energy in the house or type of college degree of the homeowner, if they have one or not, or marital status, you could do so. Bring it over and filter and sort and build your bunch of histograms based on that. And in fact, nothing wrong in doing that. Let's bring over marital status. That sounds like a fun variable. We'll add that in. Nice. So now we have marital status and age of dwelling. And before I go too far, I like to sort. So home menu, sort. Custom sort. I'm going to first do it by the marital status. That gets me grouped into filters of married, not married, wed, single. And there's a D for divorced. I'm going to add a level to then subsort by the age smallest to the largest. So I'm doing a double sort. First, group my numbers in my column on my left here by marital status and then by the age. Boom. And so what I have here is divorced, married, not married or never married, single, widowed, and these are my 4 subcategories. So now I can build a histogram for each one of these. So now that I've sorted on divorced, and I got the age of the dwelling, how old the house is for the divorced members, I'm just going to highlight the divorced members. I'm not going to highlight the D. That's not what you build a histogram based on. You build it on the quantitative data. You can sort and filter by qualitative, and that's what I've done. But when you build a histogram, it's based on quantitative data. So here I have the data highlighted. All right, insert, recommended. Hopefully the histogram comes up and you can see, well, that's Pareto. That's a special type of histogram, so that's not what we want. So histogram is not in here. So go to all charts, histogram, and there's our histogram. Click. And to be honest, we don't get a helpful histogram. And the other notice is the bins. There's a lot I want to say about this histogram, but to me, this histogram is not well built. This is where I would state I'm not a fan of the histogram right here. I'm a fan of building your histogram from ground up. I do want to mention you can play around with the histogram if you like. Notice I clicked on this interval right here. When I click on the interval, brings up the format axis piece. So click off, get rid of this, it's no longer here. Well, I'm not on the picture. When you click on the picture and click on the range here, you bring up the format axis. You could add more, you could add how wide you want your bins are. Bin width would be how long apart these numbers are. Notice these numbers are 25 apart. They pick 25. All right, these are 25 apart. These are 25 apart. If you want them smaller in width, you can write in 10. And then it'll automatically rebuild based on 10. So it's not a bad way to build quickly and efficiently a histogram. It's just not the way I'm choosing because it arbitrarily picks a start point. That is the minimum. I don't like that. I like to have everything covered, and I want to show you how I build a histogram. But please keep in mind, you can do a quick examination of your data via the Excel histogram. But you also got to be mindful of how many bins do you want, how wide do you want the bins. And in fact, I'm going to talk about that as I build the histogram for the divorce, for the married, for the never married, for the single, and for the wed. So for the divorce, the first thing I want to do for each one of these is look at the low and high numbers. So let me pause, right click, insert, want an extra little piece here, min and max. So let me show you how to find min and max quickly. So the thing is, this is sorted, right? So there's your minimum, equals minimum. Maximum divorce, that's pretty easy to see, boom, equals maximum. Equals married minimum is that number, boom. Equals maximum, just go down since it's in order, and you find your maximum to be 64.85. So I'm filling out this chart. This chart is going to help me because I want to build my histogram properly, not the way Excel does. Excel does an okay job. I just want to be able to do a better job. So not married. So not married is right here. And so there is my not married. If I want to do this faster, I could go here, make sure on the home menu, I can utilize filter. And I can filter on the category I'm working with, the not married. That'll be easier to see my mins and max. My maximum for not married is 64.9, but if you notice, it also kills a couple of columns I'm working with. So filtering, I guess, is the not best option here. So the best option here is just for me to scroll down, find the not married, and find the maximum. Single, well, equals single, minimum. And I know this is tedious, but I want to show you what I'm working with and how this is helpful. Now, there are commands you can write that would probably be easier to write an if-then statement, maybe with a minimum. If we do min, let's see, min if returns specify a given set of conditions. So we could try min ifs. Min ifs. So let's see, minimum range. So where are we looking for the minimum? We're looking for the minimum in this column. The criteria range is here. And the criteria is if we see a W. Let's see if it'll find it for us. So according to my min ifs, I'm looking in the B column, looking for the minimum in the B column. As long as in the A column, I see a W. So what it's doing is this is looking for all the W's in column A, and it finds the minimum in column B based on that. Let's just check it out. 1.96. And there it is. Excellent. So min ifs is an awesome command. There are a lot of awesome commands that make your life easier. Let's see if there's a max ifs. There is. How do I know what it does? I read. And that's it. Returns the max value specified by a condition, max ifs. So I read again. It says range for the maximum. I want to find the maximum here. Comma, where's the criteria? Somewhere in here. What is the criteria? I want a W. And that's the maximum. Cool. Please play around with count if, sum if, average if, and in this case, max ifs and min ifs. Really cool functions that help us quickly build these summary tables. Remember, we haven't gotten to the pivot table yet. Sorry, not the pivot table, the frequency table. To build a frequency table and a histogram, you need these values. Why? Because when I build my frequency table, I need to lay out the min and max values. They're called the bins. Now, how does one choose bins for a histogram? These will be the rectangular boxes the numbers will be chucked into. I like to look at the min and maxes. If the min and maxes are not too far apart, I can use the same bins for both of them. And in this case, I get lucky. I notice a number that's lower than all of these is the number 0. It's a great way to start. All right, a 0 number is, there's no numbers less than 0. I like to have my bins, making sure that my first bin, there's no number less than that. So really this bin will be empty. Also, I look at the max and I try to go one bigger. So my maximum I see here is close to 64. So if I go to 70, I'll clearly clear all the maximums. Notice my smallest bin, I want it to be smaller than any number I see in the minimum. My maximum bin, I want it to be larger. Now, if you have a set of data where they are really varied, let's say for some example, the married was very different than the mins, max, the rest, I would not use the same bin numbers. I would change them to better suit the data I have. That happens. I'm just using consistent bins if I can. Now, I notice I'm going from 0 to 70. Here is where you get freedom of control. You want to cut up the age now from 0 to 70. To me, the simplest way to cut it up is by tens. 0, 10, 20, so on. Once you have two numbers in your pattern, you can highlight the two numbers, and then you notice this green rectangle, you can fill in the pattern down to the number we wanted. So notice these bins are from 0 to 70 cut up by 10. Why did I choose 10? Because it felt like it. It seemed like a nice way to say it. Every 10 years living in the house. That is the age of the house, not living, but how old the house is. Maybe you want a finer cut, more than 10. You might want to go by 5. So 5, 10. All right. And again, once you've done 2, you can continue this pattern up to whatever number you want to stop at. We've chosen 0 and 70 to stop at. 0 is smaller than the minimum. 70 is bigger than the maximum. I choose the bins wisely. I choose smart numbers. These are the same things that Excel cuts up automatically, but not so easily. This is the first thing, and these will be the frequency tables I'm building, by the way. If you have very particular frequency tables you want to cut up the bins according to the frequency tables you want, because the frequency tables that I'm building are the bins. Let me show you what I mean. Now that we've done all the prep work, that is, we brought the columns over we needed. We sorted because I want to build a histogram for divorce, a histogram for married, never married, single, and wed. I want to build a histogram for each one of these. Got it. To do so, I need to build bins. What are bins? Well, think of bins as boxes. I want to put numbers into boxes based on Excel. So how do I do that? Well, here we go. You first have to go to your data box, your data tab. If you don't see data analysis, please look at the instructions or Google how to add a data analysis package in Excel. It's like 5 steps, but you can do it. Once you've done it, it should be there forever. So data, make sure data analysis is there. If it's not there, please pause the video and add the data analysis package. Now that we have a data analysis package, we click on it, and there it is, histogram. Click OK. All right, I read the instructions. Input. Input are the numbers histogram wants to drop into boxes. We're going to work on the divorce, so just the numbers, please. Just the numbers. No title, no nothing. Just the numbers. Got it. Bin range. Let's start with the classic bin range by 10. Oops. Notice I didn't check box. Do it again. Age. Good. Click carefully. Bin. Nice. If you did highlight labels, you could click that. I don't highlight labels. All right. Chart output, because if you don't chart output, it doesn't do anything. So we need a chart output. And output range. Where do you want the picture? Be very careful here. When you click, notice you also got to click again to say where you're going to put it. So click output range, but click back in here. Now go find an empty spot where you know bottom and right, it's pretty empty because you're going to be putting some information right here. Let's click OK. And there is my frequency table, and there is my histogram. And this would be the histogram of age based on D, based on divorce. So this is my histogram of my homeowners based on age. Now that I have this picture, I can now comment on what it means with divorce. First of all, what shape do I see? And that's really what it comes down to is once I've built it, and this is how you build a histogram, we're done now. We now look at this and ask a couple questions. First question, is that fine enough? Do you want to see it broken down by every 5 years? If you do, revisit the steps and add in the 5 years. If you're satisfied with your histogram, now you can move on to the next phase. That is, what shape do you see? Well, I see a very high mound on the low side. And then I see this incline and a quick drop off. To me, this would be skewed to the left. Notice, this would be symmetric here, but then there's a long draw out to the left. I'd call this skew left. So I'll put that up here. I'll put skew left for my data. So according to my divorce data, I'm skewed left. And you can see that because there's a high mountain and we drift off to the low very slowly. So that's left, the tail of the directions. There is a bunch of people in this age bracket divorced that own houses. Look at the peaks of the bars. But there are a few divorcees in the age where the house is only as old as 20, 30, or 40. Most of the divorced people are living in houses that are older. Interesting fact? Don't know. You can investigate that. I'm just reporting on what I see in the data. If you're wondering how high the boxes are, please look at your frequency table. This is called a frequency table. In bin 10, there are 6 people in that bin. And in fact, we can look them up. So bin 10, what does bin 10 mean? We should pause on that. What does bin 10 mean? Well, bin 10 means any age that is 10 and above up to 20 for divorced. And in fact, I'm wrong in that statement as I look at my data. Bin 10 would be people that are above 0 but less than 10. So I want to correct my statement. Bin 10 are numbers from 0 to 10. It includes 0 but does not include 10. So we got to make sure we're very clear on where 10 falls. And actually, once again, I want to clear the definition one more time. Bin 10, these are the numbers. The low number in this bin would be a number just above 0, like 0.001. The highest number in this bin would be 10. I want to make that very clear. Bin 20 would start at 10.001 or something of that nature and go all the way up to 20. It's very important to me that you see that each bin, there is no overlap. If a bin overlapped, that would be an issue. So what I'm seeing is if I look for a house between just over 10 years old up to 20, there should be only one in my data set. And there is. Right there it is. And that I can color code as red. And so that would be my red. I want to make sure my bins are clear. So bin 30 would mean any house that's just over 20 years old up to 30 in age. Again, there's no overlap. So if you get a bin, if you get a house that fits into 2 buckets, that is not a properly defined bin. So in this case, bin 30 is from age just above 20 to age 30 exactly. There should be 2 houses, and there are right there. And we can cut up our world based on these bins, and that's very important in what the frequencies mean. A frequency table is just a summary count of your bins. How do you choose the bins? That's up to you. You have to decide how you make the cuts. You really have to make a decision on your cuts. If it's a homework assignment or test assignment, they'll probably tell you how to cut it up and you have to follow that. But in true research, you get to make the cuts. All right, let's try this again. Now let's do this data analysis, histogram, but let's do it on a different subcategory. That is input. Let's change the input. Let's now look at just the married people. So here comes the married people, scanning those in. Making sure just to the married point. Please, again, do not put in the category. The category is just so I can sort my data. So I've just picked the M's, the married. The bin range doesn't have to change because it's the same bin range. We already talked about that. The output, I'm going to have to put it somewhere different. I do not want to put something on top of where it was. So the output, I got to pick a spot, click, where again, bottom and to the right is empty because here it comes. The frequency table and the histogram for age of house based on married people. I see this as uniform would be the word I use here. Uniform means, for the most part, if I look left to right, the heights are relatively the same. And they do look relatively the same. And if I look down at the counts, all right, so there is one high point at 24. But for the most part, the counts are evenly spread. So I would put a uniform on this. It's not really skewed to the right, that is a tail going to the right. It's not really skewed to the left. And it's not really symmetric where a high point and comes down. You can almost say there's a double symmetry here. Symmetric point around 60 and a symmetric point around 20. Interesting point there, right? A double symmetry, you could say. Bimodal, you could say, if you'd like to use that word. There's a lot of ways you could describe the age based on married. Cool. And this is the thing you get to do. After you've built these histograms, you get to talk about them. You get to explain the patterns you see. Notice I picked off the mode, right? The age of the dwelling seemed to center around 20 and 60. It seems to be in common with the divorce around the 60. Interesting. Maybe this neighborhood has a lot of older houses in it. Interesting quality. I would, of course, pretty this picture up. Age based on M is not really a great title, so make sure you have a better title. I don't have axes here. I probably should put an axis here to say age, right? Bin is kind of generic, right? You should make this prettier by using the plus and choosing titles and errors and things of your nature you would like. Cool. And you can continue on building one for each and every one of these places. And that is a great thing to do. In fact, I want to do that really quickly because I want to show you something. So we just did it for married. So now I want to do, once again, data analysis, histogram. I want to now work on never married. There's never married. Highlight those. That should be pretty quick. Yep. Never married. There we go. I should be careful on never married. This is not married. This is single. Not married, single. So there's two levels here, so we want to be careful. Or that might even be newly married. This is a great time to stop and say that this professor right now, I'm not sure what the NM stands for. I was thinking never married, but how's that different from single? So you should understand your variables, because if I'm going to talk about them, I should know their differences. So I apologize on that. It does not mean I'm building the histograms wrong. I just got to be careful when I explain my presentation about this. All right, M14 looks good. I like that. Click OK. Oh, nope, I want to cancel. I want M14. I want it there. M26. Awesome. And gotta be careful. So this is my histogram, age based on NM. I would call this, that's a tough call. I actually don't know what I would call it because there's a couple peaks. If I had to hedge a bet, I'd still put it in the uniform area because there's pretty equal across from a bunch of these. It doesn't fit in the skew left or skew right or the normal range, and so I'm trying to keep, or symmetric range. Symmetric, normal, uniform, skew left, skew right. We have all these beautiful adjectives to describe histograms. This one, I guess I would say uniform again, just because of how roughly equal the heights are. All right, let's continue on. And you should be pausing now or fast forwarding so you don't have to watch me build every one of these. So we're at the never married part, I think it, NM. Then we have the singles. Got it. So now I need a spot to put it. That spot, we'll put it here. Beautiful. This time I didn't click chart output, and that's fine. So I'm not going to have a chart for age based on single. That's okay. I really only wanted this bin and frequency for a reason. So let's continue. Data analysis, histogram. Actually, that chart somewhere, because I said chart output. I gotta go find it in a second. So we just did NM. Now, or no, we just did single, didn't we? So now we have wed, our last one. So we have the WED. Excellent. Still the bin range hasn't changed. Please notice for this whole process, we've been using consistent bins. If your bins are not consistent, you have to change according to the non-consistent bins. We got lucky again, the min and maxes did roughly match, so I could use consistent bins. If you can't use consistent bins, that's okay. Just note that. I'm realizing my pictures are up here. And that happens sometimes in Excel. I'm realizing my pictures are up here. Now I want to be careful to make sure I match. You know, it could be a cool little question. Which histogram lines up to which frequency table? Well, look at the counts. You know what I mean? Look at the counts. 10, 20, 30. So 20 is high and it's roughly around 10. Beautiful. Over here, none of these numbers get above 8, and that's true. So this would be age based on, so this would be the single. This time, I would actually use skew right. I do see a tail to the right in this set, right? Comes up, but then drifts off to the right. So singles seem to normally have younger aged houses. Interesting. Up and then drifts off. There are few people, few older singles that have older houses. So that's a skew right. It's good to see all these differences, right? Skew left, tail left, uniform. That also, by the way, fits under symmetric. Symmetric means you can kind of cut it in half and it looks the same. So I guess we could use the word symmetry here if you don't like uniform. Symmetric again, because if you cut it here in half and fold it over, they look pretty similar. Skew right because it climbs and then drifts slowly to the right. So that's why it's called skew right. So that's cool. We're getting all these adjectives of histograms right in here. This guy, once again, I'd go with symmetric because if you fold it in half, they kind of look like carbon copies. This would be age based on W, and I would use the word symmetric here. Symmetric is just a generic term that says if you look in the middle and bend it in half, the picture in half, they kind of look the same when you bend it in the middle. Uniform is a special symmetric, okay? Under symmetric, you got a bunch of fancy adjectives you can use, like normal. I'm not going to use normal at all anywhere here. Then you also have uniform, which I did utilize up here because it did look uniform. It is definitely symmetric because you can fold it in half, but it's also uniform because they're roughly all at the same height. We have all these beautiful adjectives once you've drawn the histogram. You have skew left, tail to the left, uniform, equally spaced. It's also symmetric. You have skew right, which is tail to the right. And then we have symmetric, which again just means when you cut it in half, you fold it over, they look roughly the same. There is a very special symmetric we're going to study a lot called normal distribution. We'll get to that later. Excellent. So we've just drawn a bunch of histograms. These are all histograms. The problem, and that's why I want to pause for a second, the problem is that there's too many. You want to fit all of these on one diagram, it's going to be a pain in the butt because you have so many. Or if you want to do PowerPoints, you want to have one per page, I guess that's good. But if you want to talk about it, you're going to be scrolling between PowerPoints before people see it. I mean, there's not many pictures here, right? There's not many categories. There's only 5. So you could probably fit 5 on a PowerPoint, not too bad. So why am I talking about this? Why am I really stressing the fact I have 5 histograms? Why am I worried about fitting them on one PowerPoint? Because that's my problem. I like to have a picture that's easily readable. And to me, when I have more than 2 or 3 divisions, like in this case I have 5 divisions, 5 subcategories, I would probably build a polygon instead. So, all right, how does one build a polygon? Well, here's what one does. So I want to pause for a second, let you have a chance to pause, catch your breath, and when we come back, which is right now, when we come back, we're going to build a polygon. To build a polygon, another shape, you would need the frequency tables, like I'm copying over. You don't need the colors. That was just to illustrate how to build a bin. and what a bin means. Because it's important to understand everything here. What is a bin? What are the limits on the bin? What does it mean? These are all great questions you should understand. How did I choose the bin? That's up to you. It comes to the data. You look at the data set and understand that. What does the number here frequency mean? That's how many people in the bin. How low and high is each bin? That's very important. When you read a frequency table, you have to understand those ideas. All right, this frequency, that frequency is for the D's. I'm also going to want a frequency for the M, for the NM, for the single, and for the wed. Okay, how do I get the frequencies for each of these? Well, we have them. We just have to copy and paste them to a summary table. This would be a frequency summary table. Often people like to see it all at once, the data. And so I'm just, believe it or not, just copying the frequency tables over. So yes, you have to build the frequency tables first before you can build a polygon. Whoopsie. Let me undo that step. Notice when you make a mistake, you can use the back arrow. I wanted to copy. I pasted instead. So here we go, paste. Nice. And so I now have a beautiful frequency table breakdown. And I can look at the counts and look at how uniform or non-uniform they look, compare and contrast them. Sometimes it's not easy. First of all, let me get rid of the color, no fill, because that was distracting me. And now I would love to look at these, and I can look at the numbers, but maybe it's better if we look at a visual display instead, where we're only a few steps away from building a polygon. So the first thing you need when you're building a polygon is you need these summary tables, okay? So you need these frequency tables. Once you have the frequency tables, you can put them together, like I did, to build your polygon. You will need to insert before your first column of information a midpoint. I'll explain why you need a midpoint in a second. But your midpoint, the reason you build your bins smartly is so you can find your midpoints pretty dang easily. So let's go back to the definition of bin 10. Bin 10 are the numbers from 0 to 10. All right, the numbers from 0 to 10. I'm being very loose on the definition, but the numbers from 0 to 10. Halfway between that is 5. Bin 20 are the numbers from 10 to 20. Halfway between them is 15. Bin 30 are the numbers from 20 to 30. Halfway between is 25. And after a while, you realize there's a pattern, and you can copy that pattern along. And the pattern does persist down, but I'll let you know, I mean, if you want to evenly space, you can continue the pattern down by 10, so that would be -5. The midpoint would be -5. Though the cool thing about the first and the last bin, they have no numbers in them. That's right. If you follow my protocol, you should never have a single person at 0 on the first and last midpoint. That was built by design. I don't like this more bucket. The more bucket means it can go at any number higher than 70. What numbers are higher than 70? A lot. And so with that in mind, I don't like having numbers in these first and last rows. That's just built by design. In case you're wondering why I picked the bins again lower than the minimum and higher than the maximum. The whole reason I picked a bin lower than the minimum and higher than the maximum is to ensure that I got this consistent 0 across. I wanted nobody in the more bin and nobody in the 0 bin, to be honest, if I could. The lowest bin in this case. That'll just make my polygon easier to build. Once you've built this table, all you have to do is highlight the numbers, the midpoint included, highlight the midpoint in the numbers, go to Insert, Recommended, and it should come up as an option. And there it is, the line chart. Or if you like line with dots, you can choose the scatter plot, your choice, line or scatter. I like the dots, so I'm going to choose scatter. And now, what is really cool about the polygon, really cool about the polygon, is the fact I have 5 plots in one plot. I have the divorced, the married, the never married or not married, the single, the wed. And I can now look at these polygons and see the similarities and differences between each one. Notice the big high spike of the married, right? The married clearly has higher bins. Now you got to be careful. These are counts. And there's clearly more people married than the rest. So that is a reason why it's so much higher. This is one of those times when you're looking at polygons, and not just one of those times. After you're done building a polygon, you need to pause and think about what it says and if it makes sense. If you're not paying much careful, this polygon looks like it's dominating, right? Woo, dominating. Well, that's because there are a ton more married people than the rest. So if that's what you want to bring out, that there are more married people in houses than the rest, then sure, that's for sure true. If you're looking for other patterns, like where do the peaks seem to happen? Do they all seem to always happen at the same spot? Like for married, here. For never married or not married, it's here. What we're looking for is, do we see patterns? And what patterns do we see in these pictures? And that's left for you to decide. And that's what you write up. Once you've built the polygon, you can then spend time explaining what you see in the patterns you see and what those patterns tell you about the housing industry in this market. Thank you guys for watching my video on quantitative variables, histograms, and polygons. Please, one more time, let's refresh. When you have a data set and you're looking at age, a quantitative variable, you would not do a pivot table, you would not do a pie chart or a bar chart, unless you want to break these into categories and do age groups. If you want to define a new column, call it age group, and call it a young house, an old house, a medium house, you can do that. Fine. That's one way to change a quantitative variable to a qualitative variable into pivot tables. You could do that. We're not doing that here. In this case, I'm looking at it as a quantitative variable. But I wanted to break that quantitative variable down by marital status. So I needed both columns. Now I sorted on both columns. I first sorted by the qualitative variable, the category variable, to ensure I got all the D's together, all the M's together, all the NM's, all the S and the W's together. That way I could find the min and maxes by these nice commands, minifs and maxifs. Why do I want the min and max? Because they help me build my bins. Notice I didn't use these bins. We can now follow my steps to rebuild with these bins if you like, to decide which pictures you like better, by this bin or this bin. I kind of like this right here, so that's why I'm staying here. So I always choose a number lower than the mins you see, 0. I choose a maximum higher than the numbers you see, 70. And I just choose obvious numbers. Do not choose decimals if you can. Choose obvious numbers because you're going to cut these bins up, whether it's by 5, 2, 5, 10, 20, whatever the cuts may need to be. I cut by 10. It just made sense for age of house to go by 10 years. Now, data analysis has the histogram. And I used the histogram and I built each one of these frequency tables and histograms using the data analysis package. You need at least a frequency table to build the polygon. Why would I build a polygon? Only if I have probably more than 4 histograms. 4 histograms I can place nicely in a PowerPoint together, stacked together. 5 is kind of weird. So with 5, I go to my friendly polygon. And so the polygon, I do need a frequency table for each of these that I combined into this table, summary table. I created a column called the midpoint. Why did I do that? Well, last thing to explain. The polygon utilizes the points in here, the points being 0.5, 6, 5, 6. If I go in here, I'll find the point 5, 6, 0.15, 1. If I go in here, I can find the point 15, 1, right there. Notice, highlight series D, it says point 15, 1. To build the polygon, I need to have the points that make the polygon happen. So again, highlight the point here or just hover over it. That's the point 1524. If you look at it, bin 20 has midpoint 15, height of 24, and that's where that point's coming from. You should always be able to explain how each one of these points came about. Thank you guys for watching this video.